We might have a live stream.
Live streaming is on.
Yep.
Live streaming is on. All right. Welcome to the Maker Experience Plus Plus. Evidently, we're live streaming. Who knows? All right. So I have Gene and Neil and Brian here. So that's awesome. And Gene up over in Facebook land found an article that was pretty awesome. It was called Face Recognition with Python in Under 25 Lines of Code. So I'm going to switch my screen to that. I wonder if, since I'm streaming from Jitsi, if I can do something like pin my screen. I guess I don't know. I wonder how exactly it renders the recording. Whether you get everything. Anyway, so this is pretty cool. I've used this face recognition code that's been in here before. So I've got some pretty weird experiences with it. And then the other part is this one, it has uses OpenCV for the camera action. So that's pretty interesting. It says here, make sure to use OpenCV v2. I'm not positive the OpenCV version stuff is going to matter too much, but we'll find out. Also saying, do not skip the article. So there's some stuff going on here. So let's see what this article has. So OpenCV. So that's Open Computer Vision. It's originally a C++ library that has bindings for Python, and it's really taken off. So you can pretty much, it's your Swiss Army knife of tools. So one of the key things is, let's see what is, so OpenCV has some machine learning algorithms built into it. Again, Swiss Army knife. There's a bunch of different ways to classify faces. So there's several options inside, but there's what is it? They call this a classifier according to this. So you're going to classify faces. You might have 6,000 more classifiers, all which must match the face to be detected. Yeah, so this is interesting because a face could be upside down, left, right. It could be like smushed up against another person. Faces appear in many different ways, so that's why they're saying, hey, well, maybe there's like so many ways faces appear. So what they use is a cascade, and the library inside of OpenCV is usually HAR cascade, HAAR. So in this case, they're saying it's like a series of waterfalls. So it's kind of like you look at a general selection and you keep sieving down waterfall to waterfall as you become more confident that you're finding faces. So it's kind of the technique. So it sounds like they're going to use the cascade process. So let's see. So the cascades themselves are a bunch of XML files that contain OpenCV data. So since this is an older thing, it's not using like NumPy and a bunch of other things for its data. It actually came historically from the time when like XML info was like yeah, that was the cutting edge for holding your data. I'm sure it's transformed and like in binary and stuff in that library, so it's pretty efficient. But it uses a pre-trained set of data, and that's the key part, is that the features about faces are stored or collected in these XML files, and how often those are updated, whether or not it was only trained on white dudes, things like that all matter. So that's something to keep in mind.
So is that data trained on white dudes pretty much that's available right now?
Well, it's unclear. So like if we do search XML, this one, we'll do HAR cascade. So it's actually the cool part about OpenCV. It goes through all the features. So the theory is like edges and lines, images, and it's sort of looking for patterns. But you'll see, like, yeah, there's a white dude or a semi-white dude or a grayscale dude on this particular image. Now, it's not representative, but that's just, again, this code, this has been around for a long time. We're looking at the C++ part. So, okay, here's a woman, and then it's identifying face and all those elements. And you'll see down here, it says har cascade I tree glasses.xml. And that's the deal, is this is a custom one that's using har cascade. It's using an I and probably a tree structure and something about glasses. So it's going to have a little more robustness because that data was adjusted. So one of the things you can do is you can dig into this stuff and figure out what they used. So if you have the time, you can dig down and figure out what's going on. But that's the what is it? So that's this thing, is like, if your algorithm performs, it could perform really well for you or like your setup or your lighting, but it all is about what is that data set. So this one says the final classifier is a weighted sum of weak classifiers. The weak ones aren't able to actually conclude if you have a face, but they're essentially a clue that there's a face, and then those clues are put together to grab, say, 200 features with 95% accuracy. So the final setup had about 6,000 features, which was a reduction from 160,000 features. So, I mean, there's a lot of optimization in here. And that's the other part, is like, if the data set is skewed a little bit or one way or another, you don't really know until you try it out. So that's actually one of the very first things to do, is actually try the stuff out. So that's what that's kind of like going down this rabbit hole. It's sort of like, yeah, you go down the rabbit hole, but you need to give it a go. But that's the deal, is this XML is like the data. And in the way, like, say, TensorFlow, PyTorch, all that works, those would normally be like NumPy files. And so you just convert your XML to NumPy and you're good to go. And they probably do that under the hood. But the raw data was in this XML format. All right, so installing OpenCV. I'm not going to install it in this case because I have it already on my system. But there are tutorials for getting it going. And the reason for this is that, like, OpenCV runs on all kinds of systems. So running back over to OpenCV land, I mean, there's an Android build, there's Windows builds, iOS, Android, yeah, and as like also Raspberry Pi, for instance. But compiling, like, you have to cross compile to get iOS and Android, or you get the pre-built binaries and all that. Same deal, Windows and Mac, you can get pre-built binaries, but sometimes you like them or not. That's the other part. So they may not have all the optimizations you want, and then you go to code and compile it. Raspberry Pi, you used to only be able to compile it, but nowadays, if you follow the instructions over at PyImage, search for OpenCV and Raspberry Pi, this site has like a step-by-step guide to either do it by, and it's right there, OpenCV install guide. So like, you either like with pip, which is the quick way to do it, which is the pre-compiled binary, or like how to build it from scratch on all these different systems. So that's also super cool. But to get to the bottom of this quickly, I'm just going to skip that. I just wanted to point out, like, it's kind of cool, OpenCV's on iOS and Android. So that means that things that you can do with, your one environment, you can move to another. All right, so that's a cool one. So they show an example here, import CV2. I also mention, so in my case, I'm going to make a directory. I'm going to go call it Scratch, and we'll just use this to play around. So I have, basically, I'm on a Mac system, and I've already got most of these things on here. So one of the deals is Python 2.7 should have been deprecated, but let's find out. Like, yeah, Python 2.7 is still default for so many things. So if I do Python, I'm going to need to do Python 3 on my system. And then I did the work to get CV2 on here. But here's the crazy part. CV2, like, there was OpenCV1, then there was OpenCV2, and instead of CV3, CV4, CV5, etc., everything is now CV2. So I think if I do print CV2 dot underscore version, there we go, I'm running 4.2. So this article was indicating that it needed something about version 2 of OpenCV. We'll cross that bridge when we get there. So understanding the code, let's break down the actual code. So they have a repo. We like that. We like things in a GitHub repo so we can dig into them. FaceDetect.py is going to be one script. abba.png, Harcast score, frontal face, default.xml. So there you go. This is that Har Cascade business, and it's got an XML file, and it's front faces, not sides of heads and other things. Like weirdly, all of those things. Like if somebody comes and walks in with a side of their head, it's suddenly not going to be a face. And does that matter to you? Good question. All right. So Python, they've got get user supplied values. So this script here, face detect, evidently is going to say, hey, where's my image path? Where's my cascade path? Kind of like, where's my data? Where's my image? Figure that out from looking at that. Now let's see. Let's go over and look at this here. Shantnu face detect. There we go. Cool. So this has actually got everything in it. And I'm like, all right, let's get this going. So I want this code. I could download it, but I'm just gonna clone it. Click the whatever. So Git. Now we can always dig into Git too, but in this case, let's get out of Python. I want to do Git clone, and I want that repo. So now I have everything from over there, and it's face detect, and I've got all those scripts. So a couple different ways of looking at this. Let's see what. I guess I give everyone the option. We can either look at it with like Vim, or I can load VS Code, Visual Studio Code, to take a look at things. Any preferences?
Nope.
Okay. Well, Visual Studio Code is pretty cool. Let's just give this a shot. So what I can do is I've got that running. So code dot. Also, if I had been up to speed, PyCharm would also be fully awesome way to go with this too. So in this scenario, I've got, let's see, VS Code running, and then I have that web page. Let's put them side by side real quick. So hopefully this will go on the right. This will go on the left, and won't be able to jump around to these articles. Okay, so they wanted FaceDetect.py. So let's look at FaceDetect.py. And I should be able to, my side menu, I need it to go away. So the W? No. I have a window I want to get gone. Weird. I have to pull it wider and then make it go away. Oh, click on it. Dirt. All right. There we go. And then where did my... Oh, let's undo that. So what it did was it makes the other thing full screen. It's like so super helpful. All right, let's go left. And then Visual Studio Code on the right. Oh, this is a different project. I've used TensorFlow JavaScript stuff, and that's my facial recognition using web pages. But I'd go back over here, shift this. All right, let's make sure I have the right Visual Studio Code that I want to use first. Okay, here we go. And on the right. This is on the left. Whew. All right. So I've got everything paralleled. So on the right-hand side, it'll say import CV2, import sys. So this is meant to be used as a command line tool. So command shift this, no. All right, so I'm going to add a terminal window to my VS Code. So now I've got everything all on one screen. This can be pretty messy. So, all right. So the idea is that we've got to get your image that you want to use and the cascade path. All right. So CV2 system. So here it is. And then it's saying there's my XML file. And then we need, the code is create a facial cascade. All right. So that basically is what it's doing. It's got, again, Swiss Army knife. It's giving you the tool. It's not telling you how to make the tool. It says you need an image, and this will walk through the logic of it. Okay, so we've got an image that we're going to tell it to go find some information out about. Then what you do is it says we got to convert the image to grayscale. So this is a classic one, which is like if you're doing image recognition on full color, you know, it's 3 to 4 times the amount of information. You might have an alpha channel. But what you want to do is, in this case, is if you bring it down to blue, gray, red to gray, it gives a pretty accurate transformation from your color image to a gray image. And that's way better data-wise. So you're only looking at maybe 256 pixels versus, you know, 16 million or some goofball thing. So faces, that's the next part, right? You want to know what your faces are. So you use face cascade detect multiscale. So you say, I'm going to use the gray image. The scale factor is going to be a 1.1 to 1. So this is another thing, like, are you making the picture smaller, bigger? What's going on with your scaling of the image? Like how a big close-up of a face versus a pullback with 5 faces. There's definitely different sizes. So if you cluster, like if one photo is the size of a nose, it might not recognize the nose, the face that the nose is in. Anyway, it can be kind of like, here's my big head, my big face, and then I might have like lots of little pictures. Well, how do you know where you're looking for faces? So in this case, it's doing a little scale. It's also going to say we got something called neighbors. So we want to figure out neighbors, and then the minimum size, right, is a 30 by 30 pixel. And then it's got a flag saying har scale image. So that cascading, I think, also has a feature where there's like look for big faces, look for small faces. All that can be there. And then it's just going to say, hey, did we find faces? Okay. And then for each place there's a face, put a rectangle over that face. Then let's go show it. And then wait for the wait key and kick out. So that's the actual code. What did they say over here? Understanding the code. It's got the path to the XML file. That makes sense. Convert it to grayscale. Makes sense. It says also, it may be also everything is, it may be trained in grayscale. So to use color wouldn't work either. So detect multiscale is a general function that detects objects. Okay, so they're saying object detection, then bigger scale factor. Since some faces may be closer to the camera, they would appear bigger. Scale factor would compensate for that. So that's a value of 1.1. Detection algorithm uses a moving window. That's another very important concept. It's like little rectangles moving around. It says min neighbors defines how many objects are detected near the current one before it declares a face found. So basically, when you subdivide the photo into these little windows, you try to figure out how many neighbors you have, and that gives you a minimum number of faces to find. So it's somewhere around 5. So if you had 6 faces clustered together, it might still get all 6 faces, but if it doesn't happen to be in the window, it might miss something. These are all commonly used values. Of course, experimenting for different factors is, yeah, they have to do that too. Then draw a rectangle around the faces. So this is good, so you know you found the faces. And this is like CV2, again, such a Swiss Army knife. It's like, not only is it showing pictures, running a har cascade on them, it's drawing images on there, and then it actually shows the picture with the faces found. And that's supposed to work. So it says, hey, do this thing. And then it's supposed to show you this picture of ABBA. So something is going to go wrong, I can tell you right away. When we're going to try this out over here, I've got Python face detect. Well, let's see. We're going to go Python 3 face detect. And I did prove that I actually have OpenCV installed system-wide. So what could go wrong? CV2.cv2 has no attribute CV. Okay, so yeah, so this is a bug in the system, but where did that come from? Let's double check. There were some warnings at the top. And I think the top was a warning that there's OpenCV3 version of this. So this is the deal. It's CV2 original has one set of things going on. So they're not directly compatible, even though it's import CV2. It's that version stuff that's really important. So something changed in the versions, and it's this on the right-hand side. CV2.cv2 has no attribute CV. So let's just use the other one, underscore CV3. And then the other thing is we're running CV4. So if something changed for CV4, we might get derailed for that too. All right. So we got libpng warning, ICCC profile, Photoshop ICC profile, gray, color space not permitted on RGB. But it found 4 faces. That's actually what we were looking for. Now, it didn't show on my screen. I'm using this full screen madness. So what it did was when it went full screen, it didn't actually go and find the photo we expect. So there's ABBA. And it shows us the gray version. So totally worked. And then we just have to X out of this thing. I'll hit Control C over here or something. Maybe it'll let me out. Or it may just let you out when you quit properly. How about that? Woo! So yeah, so Control C is another thing you have to look for. Like, do you want to support that in the shutdown procedure? Wow. Okay. So let's look in this folder real quick. And looking in the folder, we've got some images. So what can we see here? I've got ABBA. That was the detected. This is ABBA the gray. This is I guess this is Spice Girls. Maybe the Saturdays. These all have faces already on them. This is like having the answer. All right. So we haven't really run this through the ringer yet. I need faces. Oh gosh. Where can we get faces?
Do you want to get off of Facebook? Maybe some of our old were.
Oh, let's see.
Or power racing.
Yeah, actually, I'm going to open a Chrome session up here, and then I have I've taken photos at Maker Fairs forever. So why don't I grab like a general Maker Faire photo or something?
Yeah.
Of course, one of my windows, this one went full screen. So let me go move that out of full screen, and then I think we had face detect over here. Okay, so we're good. I'm just gonna run through. This is always like the Google Photos is like the land of facial recognition madness. I've got chickens, and I was hanging out at a farm at Ben's farm yesterday. That was pretty awesome. Let's just type in Maker Faire, right? So that's just that should something terrible should show up going through that. There's people's Maker Faire planning, Maker Fairs from years ago. Let's see. I just need random crowd. I need faces. Give me faces. These are Daleks. If it was recognizing Daleks in RC cars, we'd be in pretty good shape. Oh my god. Crowds. Faces and crowds. Almost. Very impatient with these things. All right. Here's one. This is a photo of people having raced, hanging out. I'll just do... so this has got a few different features. I'm just going to screenshot that. And then I'll go back over into my folder. Go copy from desktop. Screenshot. I have a bazillion of those. Well, of course, it once. What's today? 2020. 0920, right?
Yep.
2020 0920 22 at 219.48, almost at 220. We need to wait. I'm missing the moment. I got to take a screenshot right now. Here, I'll sub sample there. All right, and I want to copy this as like PRS1 dot, and it was a PNG file. All right, and then I have another one. Let's see here. Yep, I got my 220.29. Almost got 2.2.20. So anyway, let's grab that one. Oh, I overwrote it. Oh, make this one 0. Okay, so I'm gonna run it from the command line over here. No, it doesn't really matter. I'll go over to Visual Studio Code. We can run from there too. Okay, so we have new photos, and if I type history, I'll figure out, yeah, I had OpenCV3, and then I needed a PNG file and the har cascade stuff. So be actually easier to flip the commands because you want har cascade like all the time. And I want to try different images out. So let's do PRS0. Right, and it's going to do grayscale automatically, all kinds of fun stuff. So let's find out what happens. Found one face. So if I do that, that's not a face. Okay. And then let's try this one. 0 faces found. So there's definitely something going on, like those scale factors, all these different things. So what you needed, I think, are people who are the same ratio as all of these things. So if I did, what would be a good ABBA style shot? Oh, wow. I know those people. All right, we'll do something like these people are ABBA.
And they've got glasses.
What's that?
And they've got glasses too.
Yep. So we have different features. So let's see here. Do that copy again. And I'm going to make this PRS2. And we want the 22 one. Ooh, the fan on my computer finally stopped. Holy smokes. All right, so this one is more of the scale.
I didn't find anything matching holy smokes on your computer.
Yeah, I have this Siri problem on my Mac. It doesn't find lots of things on my computer. Oh, man. I so distracted. I lost track of what I was doing. Oh, my God. So let's do PR2. And I got 3 faces this time. So this is the deal. Without like a really clear data set, it's gonna try. It's always gonna try.
That was really interesting. That third face was.
Yeah.
Is it on the actual magazine, or is that just some random shape that kind of looked face-like?
Well, let's look at it again, right? I could zoom in on this. Because what it did was, so it's a cascading thing. It's like, oh, these, hit the wrong button. There's all this cascading business where, like, if it goes down the wrong, like a pachinko ball, it goes down the wrong direction. It can have some pretty bizarre things. This thing should allow me to zoom. I'm gonna cheat with this zoom. I don't know how this is gonna work, but it was a T-shirt.
Interesting.
Yeah. So
it's almost like it's triggering more on relative position than actual features.
So when we started the AI study group, this was one of the first examples I went to, because it's actually really, really simple, and it looks on the surface like if you just use it, it's going to work great. Unfortunately, it actually runs into these troubles. You end up going back over here. Gray is fine. You have to play with your scale factor. You have to play with your min numbers. You change your min size, min. And then as you dig through this, see, like, I think one is like if every picture is in this kind of ratio, you'll do okay, right? That's why you have to keep playing with that number. So, oh yeah, so this one showed a face where the woman's chest is. And so it says what was going on here. There was the first picture was taken with a high quality camera. The second one seems to be taken afar with like a mobile phone. So the scale factor had to be modified between the two photos, even though they were the same. So it says they're claiming that because it's based on machine learning, the results will never be 100% accurate. It's kind of true, but at the same time, this is misleading because the data set is where the trouble is. Your data set is bad. So this is the same data set that I used a year ago, and it's the same data set people used 5 years ago. And if you're like doing a naive, like, hey, this is really easy to do. If you had everything lined up, it's really easy to do. But as soon as you're like in the real world, things start going wrong. It can be quite crazy. Though I also love the things where you say like you extend it to a webcam. That's a part that OpenCV does really nicely too, is it will do webcam detection. So you can open a webcam, run through it live, apply the detect to it, and it can be really fast. So that's like using the webcam for this stuff is pretty cool. And that's where they go with it. But it might be fast, but it also be fast with the inaccuracies. Let me think here. I use Colab Notebook all the time. So if I remember correctly, if I use face detect, I did a whole thing on it. May have to do this for a different time, but AI study group notes, copy of pose estimations, cart hold, train SSD from Moco. Yeah. Let's see if it's in the study group notes, just in case. But essentially, what happened was we've kind of going down this path that John from the AI study group, who runs the Python Princeton group, has done something where, like, you saw how messy this was and it didn't quite get everything you wanted. He's spent a lot of time at it and now can identify thousands of faces of his own family members and run it on his own system. And so it's like starting here is a great starting place, because like in a couple of months of digging in, the whole clusters and the hierarchy stuff that John was finding with dbScan and all this additional stuff, you can really create reliable face detection. And then, like in this case, he's using it for family photos, which I actually think is way better than sort of going through your Maker Faire photos, but family photos and doing your own process of that. But for instance, this same exact code was used for like detecting people delivering packages at your front door. And this is where, when we tried it out, it was like only white people showed up. Wrong pathway here. So, and I have a video of it someplace, but I don't have it with me quick enough. So, boy. Okay, so this is the frustrating part of face detect. So I don't know if you guys have a suggestion where you want to go from here. We could just pause at this point. I do have. There are definitely better options. Let's see. So if I would want to use Keras, for instance, face detection. So when you see things like VGG Face 2, these are actually predefined models that are already trained on a variety of faces with a whole different set of data behind them. And usually these will explain the data that they have, explain the information about who was used. So data set for recognizing faces and poses, VGG style. Let's double check in here. So the procedure of cascading and finding faces is usually pretty common. And so there's the face extraction where they're finding the face, pulling it from the device. I'm trying to get more faces. So you end up getting into a more complicated scenario. But in these cases, you can dig into the papers and you can find out exactly, what did they do to make these work? And there's a lot of training on celebrity faces. So could actually be, if you're not a celebrity, it might be harder to find you.
That is interesting too, because the celebrities have the more, should we say, the ideal aesthetic, not necessarily representative of the general population.
Yep. So that's like kind of self-fulfilling prophecy in that scenario, because you also have so NVIDIA. Well, there's this is not a person.
Hey.
So this person does not exist. Hey, Ben.
Hey.
So this person not exists stuff is really taken off. So they're not all celebrities, for instance, in these particular generative faces. So it's kind of interesting. You can generate lots of faces, and here it is, StyleGAN2. I like the fact that like a site like this tells you they created a generative adversarial network. And so what that was you have one that makes a face and then another one that judges a face. And then it's like, hey, if you want to train your own, here's some code. So now if I go over here to StyleGAN2, this is actually a tutorial where we could make faces. So we could explore some of these other things. So I like the fact that face detect is easy to get into, but it shows you like the difficulties pretty quickly. And yeah, I had my team recognized as a doorknob, and Lavina and Kenny got confused with each other, and my friend Ringoli ended up being the universal shadow. Like she kept showing up as other people, but never herself. So this stuff is a little crazy. All right. Let's see. But yeah, I'm trying to think if there's anything interesting. Like this is a pretty good like arc here. I could show you the thing that I did with the Cocoa data set in JavaScript. It's pretty trippy.
Ooh, let's see.
Yeah, okay. So this is crazy looking stuff. So I'm gonna move out of this VS Code window to my webcam object detection. So it turns out there's TensorFlow.org, and so this is Google's framework for machine learning. But TensorFlow with JavaScript,
Yeah.
that's actually just running in the browser. So this is the part that's really interesting. You can get machine learning to happen in the browser pretty straightforward. I recommend Teachable Machine as just like a getting started, and I'm going to actually do a tutorial on this at one point. But Teachable Machine is a way to use the TensorFlow pattern and machine learning and training and do your own image detections and audio and pose detections, all sorts of fun stuff. So Teachable Machine, I recommend it 100%. But TensorFlow JavaScript is what enables it. So over in so I recreated this. I recreated it using I created a project using a webcam detector. So with the webcam detector, right, you're going to see me and the webcam taking pictures of things that I show, but I'm going to use the OBS virtual camera. So you can feed it lots of really weird stuff. So anyway, I used Vue and Nuxt to create a web app, and the web app is actually running here at localhost 3000. If I run Firefox is really good at crashing, so let's just see what happens. Mainly because it's like, who has the camera, right? I'm using the camera right now, and you're seeing my camera, so we're gonna see some crazy stuff. So I have Cocoa, which I'm using is the again dataset wise Cocoa dataset. This is a dataset that I keep playing with because it's just so fascinating. The Cocoa dataset is common objects in context, and it lets you, like, say, I explore it. I can say, oh, let's like streetlights or stop signs, and it gives me. So the Explorer is going to show me these things, but this is a data set you can train people on. So like, where's the stop sign? Oh, it's a clock, so it's not a stop sign. So not everything's perfect. There's a stop. That's a pretty good one. So let's go back over here to people. I'm going to set this up, but long story short, let's go over to my webcam object detector. I'm going to give it access to the OBS camera because now I can feed it. I'm not going to on Firefox. Don't click remember this decision, because as soon as it crashes, it will always crash. All right, now of course we have our infinite windows. So let's try something. I'm gonna go to me. So I'm just gonna bring me back, right? So here I am, and it's showing me the web camera, and I can do a snap photo. So I'll snap a photo, and there's me. Then I select it, and it says like, okay, well, here's the photo. That's a great shot. And then I run detect. So hopefully, first time's always very slow. And of course, I'm running a circle. There we go. So it says, oh, there's a person in there. And yeah, again, the first time is pretty slow. So there's a person shot. Let's do let's go find some fun options. Laptops. Slide video? No. Of course. Only the coolest mix-ups. All right, this is one. I'll snap a photo of this. You can't really see me snapping the photo. Now I have to go back over to my other window here. Control 2, control there. Ah! So you can't, don't look at that. All right, so I have this like room. I'm like, hey. So now I want to detect what faces, what's in this space here. So I only found one object, found me again, but it didn't find the close-up. So it's really crazy. These, let's see, laptop screen, main audio. Okay, right. So I'm back over here. I need to find something that's got like, again, people or something into it. So, oh yeah. So, okay, I'm gonna open up this thing, and I had the PRS 0 photo. Which one had lots of people? This one had plenty of people. Okay, so the way how do I gotta. Control 1, Control 2, Control 2. Okay, so this one I need. So confusing. All right, so I need to get a picture on the screen. Open. And what I want is this PRS photo. So I want this PRS photo. There we go. All right. Arrgh! I just closed it. Every time I open it, I close it. This one I want. Now it's giving it to me on a different screen. That's okay. Oh, I see what I could do. How about laptop screen? All right, so I have my laptop screen up. So in order to get this shot, I have to share. So I'm sharing the lap. You guys, if you could see what I'm seeing, it's crazy. All right, so I have to share this picture really, really closely. Like I gotta zoom in, gotta make things big. Okay, so now that I have that set up, I can snap this photo. So you can't see what I'm doing. Now the photo's snapped. So now we'll go back and you'll be able to see the photo that I took. So here's the photo I took. Now that I have it, I want to detect objects. So now it detected 4 objects, person, 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 person. So it thinks there's 1, 2, 3, 4 people. So it missed a person because they overlapped over here. But I would say this is a much more robust object detector than the face detector, for instance. But if you are slightly behind somebody, it will, it still have the problem of things getting obscured from one another.
Yeah, but Rick, it's a person detector, not a face detector, so it doesn't see a full person.
Yeah. So it's actually an object detector. So if I have a scene, so the next thing up is to find another picture that's not just people. And the way I did this before was, let's say I do, I want this Coco data set here. If I find, what I should be able to do is, this was trained in the Coco data set. So if I go and look for objects that have people and skateboards in the same photo. So I got people and skateboards, all these different. So the data set is pretty high quality, so it actually finds you these people. Now, in order to test it, I have to go to the Flickr photo version of it and see, like, hey, this is the source. So for me to get this to pop onto the, so now I have to go to my detector software. So I have to use this to detect the photo. So I have to mess with everything again to do it. So I have to use my laptop screen, which now you're seeing my laptop screen. So here I have to take this photo and make it large enough to fill the space that the camera is going to look for a picture. So like right there. So like the object detector is really good. It would find a bicycle up in the sky, but those things are really hard to see. Okay, so now I'm going to snap that photo. Get to the right place. Snap the photo. Okay, now I have to go back to my monitor, scroll up, and I'm going to say, okay, here's from that data set that was actually trained on. Now you need to hit detect. This time it gave me 3. So what happened here is that the data set that I'm using is trained on on the one data set, but it's not really like in terms of skateboard, right? It found the people, but not the skateboard. So we're always stuck having to test these things out, trying to figure out what parameters is this actually working by. And the data set that I have is not as feature rich as the original. So let's see if I pull up another one. Let's see if I can. Yeah, this one should be set up. So I'm going to do another screenshot. That looks pretty good. Snap the photo. Go back to that window. Grab it. Let's use it for detection. This one gave me 11. So let's find out. It's a person, umbrella, person, skateboard, person. So however this picture worked out, it found people way out there. So this is, and then umbrella was the actual, like, 2 umbrellas, a variety of people, and it even found the skateboard. So we know that the data sets are actually, like, since this is in the data set, we would be able to do, like, okay, is there an umbrella? And I've got 1, 2, 3, 4, 5, 6, 7 people, 2 umbrellas, 7 people, and a skateboard, right? And if I go back to my data set over here, let's find out what it actually said. So this one has 1, 2, 3, 4, 5, 6, 7. Well, let's see. Let's click on people. So clicking on people gives you 1, 2. Let me zoom in because it's got more people in here than the thing does. So let's go look for people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people are in the photo itself. But it found 1, 2, 3, 4, 5, 6. So what it is the smaller profiles didn't quite make it as people. Then it also detected a bicycle. So if you can see, there's a little highlighted area where there was a bicycle. So we didn't get the bicycle, but we got the skateboard. The umbrellas, they found the umbrellas, for instance, but we got both of those. That's good. We got 1 skateboard, but it has 3 skateboards. It's got chairs. So it pulled out the chairs, and then anything else? No. Okay. So here's the thing: is that the data set, like, since this is actually in the data set, this kind of information is used to test your algorithm. So you have the Coco data set with all these things in it. One partition is sort of like 80% data trained on, then you hide 20%, and then you give it a picture like the picture that we have here. And when you give it that picture, what happens is you're now training it. Well, you're testing your training. You're finding out how good the training actually was. Because in my data set, if I go to the database and I look this up, I can say this picture should give me, 11 people, 2 bicycles, 3 skateboards. And that's what's automated in the machine learning process, is actually, like, I know this data set. This picture was missing from the training set, and it only identified 7. So we're not as accurate as the real data, but maybe we're at 80% accuracy or 90% accuracy. And then somebody says, okay, it's good to use. So again, that HAR cascade stuff in the XML files, those are all tested with what's in there. So I would say what good follow-up would be to sort of reverse engineer and say, well, what actual features and pictures and who were in that data set? Kind of like what we're doing right now with this Coco data set was like, well, I have something that's trained on the Coco data set, so it should perform similar to the information that's collected. But they could have by hand or had a person or had a computer go through or a machine learning algorithm go through, and then a second pass of humans verifying it. You can do all kinds of stuff to manicure your data. And so like anyway, this gives you, this is the hard work of making a good data set.
Is this looks similar to the one from the Google Vision Kit? Is this like the same one?
This is commonly used. This Cocoa dataset stuff is commonly used for it.
Okay.
Yeah, it's there's like essentially when we're talking about papers and all kinds of stuff. So if I go to the Cocoa dataset again, the thing, a lot of this stuff is all at archive.org. This is all computational photography to machine learning, but they basically like, hey, look at our research paper. So the research papers, here's archive.org, for instance. So what, not only do they publish their research, they publish their code, they publish the, you know, how did this thing come about? What was all this information? What's it supposed to be good for? So if you're willing to dig down, you can actually get really down into this. Like here, it's 2.5 million labeled instances of 328,000 images. So like it's big, but like what process did they use? So for instance, we provide baseline performance analysis for bounding box and segmentation detection. That's the other thing, is like this data set is like such a rich data set. You can use it to sort of, we were using it to find objects, right? The other part about this is using it to segment the environment. What's in the background, what's in the foreground. You know, you can use this in so many different ways because you have, like, say, pretty decent labeling. And again, they actually wrote all, you know, they wrote this down. They said, this is what our data set does. It's got 91 object types. And that's another thing too. When you go to like Teachable Machine, just but yeah, so the answer, I think I answered. Did I answer your question, or did I go off topic already?
You sort of answered it, yeah.
Okay. Because the thing about the JavaScript stuff is that it's not necessarily optimized for the stuff we did with the Python code can be optimized for a specific computer with a bunch of GPUs to have high performance. And you could have all 91 classes. But what you'll see here is, like in Teachable Machine, they allow you to add up to 16 classes. So it's like object detection, except you only can pick from 16 objects. So they keep the choices low, but the images high, because what happens is the training is where all the good stuff comes from. So having a bunch of pictures, right? That gives a lot of information about, like, Rick present. And then if I go and try to hide, I can go to my class 2. And there's really object Rick present, and then like no Rick. And then all of these images, they take time for training, but what they do is they turn into data later. So you don't actually have to care about holding these images. You hold what you've learned from these images in place. But it's fast because it's only 2 classifications. Plus here, it's also the nice too, is that, so it gives you, on the lower right-hand side, it gives you an output like, yep, there's totally a Rick here. And then as I go out of the screen, there's a no Rick. And if I partially in the screen, the percentages will kind of partially have me in the screen. But it's a sort of true-false condition with a confidence that there's a Rick in the screen. But it didn't, this whole output, this whole export your model business doesn't need every single picture. It just needs the, what did we learn from all those pictures? And then that's where, like, going back to the Cocoa data set, if if the technique was learned from the Coco data set, for instance, you don't have to do this training step as much. Let me think about that. If you can train new neural networks from the images, but you can take the structure of a neural network, but a data set is simply the source. So the Coco data set has a neural network trained on it, and that was what I was using in my example of just like object detection here. So it was trained on it, so it's got so I'm actually not using the neural network of the data set. That's a neural network trained on that data set. So it's good at those kinds of things that's in the data, right? So here, this data is good at is there a Rick or not based on the colors I'm wearing or